Okay, let's consider this problem. It's a grade 12 trigonometry problem, and I notice they give us that the sine of 20 is equal to k. And if I think about the unit circle, we know that 20 degrees would be about here, and the y-coordinate of that point on the unit circle is equal to k. So there are a few ways to do this problem. One is to know that the sine squared plus cosine squared is equal to 1. That's a Pythagorean identity that comes from a triangle. So if we know that sine squared, k squared, plus cosine squared of 20 is equal to 1, then we can solve this for cosine. So cosine squared of 20 would be equal to 1 minus k squared, and cosine of 20 would be the square root of 1 minus cosine squared. I know it's positive because 20 degrees is in the first quadrant, so we don't have to worry about the positive or negative. Okay. 4.1.2 asks us to find the cosine of 110 degrees. Well, its connection to 20 might not be immediately obvious, but if we locate 110 degrees on the unit circle, we might notice that it's related to 70 degrees. And in fact, we could say that the cosine of 110 is equal to the opposite of the cosine of 70 because the cosine is the x-coordinate on the unit circle. And we do know a connection between 70 and 20. And this now relates to the co-ratio relationship. So we know that the sine of 90 degrees minus an angle is equal to the cosine of that angle, and that the cosine of 90 degrees minus an angle is equal to the sine. So the opposite of the cosine of 70 should equal the opposite of the sine of 90 minus 70, which is equal to the opposite of the sine of 20 degrees, which we were told was k. So that one is the opposite of k. And last but not least, 4.1.3, the sine of 40 degrees. Well, we might notice that that is equal to the sine of 2 times 20 degrees. And we have a formula for the sine of 2 times an angle. It is 2 times the sine of the angle times cosine of the angle. So we know that the sine of 20 degrees was k, and the cosine of 20 degrees we found in an earlier problem, 1 minus k squared. So we could think the sine of 40 degrees was equal to 2 times the sine of 20 degrees times the cosine of 20 degrees. That's the formula with theta equal 20. There you go.